simple linear regression, we predict scores on one variable from the scores on a second variable. The variable we are predicting is called the criterion variable and is referred to as y. The variable we are basing our predictions on is called the predictor variable and is referred to as x. When there is only one predictor variable, the prediction method is called simple regression. In simple linear regression, the topic of this section, the predictions of y, when plotted as a function of x, form a straight line. Some example data are shown here in the table and graph. You can see that there is a positive relationship between x and y. If you were going to predict y from x, the higher the value of x, the higher the predicted value of y. Linear regression consists of finding the best fitting straight line through the points. The best fitting line is called the regression line. The black diagonal line in this figure is the regression line and consists of the predicted score on y for each possible value of x. The vertical lines from the observed y values to the regression line represent the errors of prediction. As you can see, the red point is very near the regression line. Its error of prediction is small. By contrast, the orange point is much higher than the regression line, and therefore its error of prediction is large. The error of prediction for a point is the observed value of the point minus the predicted value. The predicted value is the value on the regression line. This table shows the predicted values, y prime, and the errors of prediction, y minus y prime. For example, the first point has an observed y of 1.00 and a predicted y of 1.21. Therefore, its error of prediction is negative 0.21. You may have noticed that we did not specify what is meant by best fitting line. By far the most commonly used criterion for the best fitting line is the line that minimizes the sum of the squared errors of prediction. That is the criterion that was used to find the line in the figure shown previously. The last column in this table shows the squared errors of prediction. The sum of the squared errors of prediction shown in this table is lower than it would be for any other regression line. The formula for a regression line is y prime equals bx plus a, where y prime is the predicted score, b is the slope of the line, and a is the y-intercept. The equation for the regression line for the data we have been discussing is shown here. The predicted scores for x equals 1 and x equals 2 are shown to be 1.210 and 1.635 respectively. The SAT and college GPA case study contains high school and university grades for 105 students who graduated from a state university with a BS in computer science. We now consider how we could predict a student's university GPA if we knew his or her high school GPA. This figure shows a scatter plot and regression line of university GPA as a function of high school GPA. You can see from the figure that there is a strong positive relationship. The correlation is 0.78. The regression equation for this line is shown here. The calculation shows that a student with a high school GPA of 3.0 would be predicted to have a university GPA of 3.12. It may surprise you, but the calculations shown in this section are assumption-free. Of course, if the relationship between x and y is not linear, a different shaped function could fit the data better. Inferential statistics and regression are based on several assumptions, and these assumptions are discussed in a later section of this chapter.